I'm Lori Parrott from Sandia National Laboratories. I want to tell you a story about a forest. In telling you this story, I want one idea to come across. That is the idea of robust yet fragile. If that's simple to you and you think you get it, I'll introduce a second idea, which is called deep information from limited observation, and I'll show you how these are attached. Forests are complex adaptive systems. That's the example I am going to use to talk to you. Many of you are familiar with the logic and the literature of complexity and systems. You heard some about it in various talks today: systems of systems, complex adaptive systems of systems. There are various bodies of theory, there are various sets of literature you can read, but the characteristics that I think about when I think about a forest are emergence over scale and adaptation and self-organization. Complex adaptive systems are important to our lives, from biological networks and genetic regulatory networks to power grids to social networks. Whether engineered or organic, these complex adaptive systems often have a similar set of characteristics that scientists can understand and use. Let me illustrate this forest fire in a 2x2 grid. You could download this on your iPad if you really find it interesting. Think of this forest fire. The green are trees. A white spot is not a tree. If a tree burns, it becomes white, a white, barren spot. If a tree grows, a white spot turns green. This you'll find in the literature from Carlson and Doyle starting back in the 90s. Now, this is where I'm going to illustrate the concept of robust yet fragile. Over time, the forest evolves to become robust against its most common threats. So up in the left-hand corner, imagine that's where the campground is, or that's where the lightning happens to strike most often. Eventually, over time, fire breaks, the white patterns you see there, develop. The forest develops a robustness against the common threats it faces. But look at all the green. It's fragile. When the lightning hits there, when the campers go on a hike, this is where you could have cascading, large, out-of-control implications. And you may not want those in your complex systems. So here's my story. Networks that evolve to improve their performance become robust yet fragile. Details about the robust features are not very informative. But details about the fragile features are the ones you really need to seek to understand if you are trying to leverage a complex system. Deep information from limited observation is a concept that's being applied at Sandia in different ways to help provide insights in an analytically economic way. With DILO, you can infer far more from a system from limited inquiries than you could traditionally do so from ad hoc ways. These are two examples where, in understanding a social network, understanding how quickly and how information went from small, tight clusters within a social network and crossed to other clusters within a social network, you could predict when you were going to have a social movement explode. With power grids, this work will be published in the next few months. You can look at, say, a cyber attack in a remote part of your grid, bus 2. There's a cyber vulnerability. Bus 2 goes down. Surprise, it affects bus 11. Surprise, when bus 2 and bus 11 go down, the entire grid falls. This chart just shows that our model, compared with some proprietary data we were able to receive, predicted the system failure very well. So in summary, I just want you to remember robust yet fragile, and I want you to think of the forest fire. If that's easy for you, I want you to think that robust yet fragile offers an opportunity for using techniques that give you deep information from limited observation. In other words, you can see the forest for the trees. Thank you.